We have already solved many time and work problems in our other channel, VAAGAI Math for You. But in this session, what we are going to see is we are just going to discuss a basic concept from time and work, where it is going to involve problems which are based on two working bodies. Two working bodies means, for example, it can be two people, they are going to work on some task, some job, or it can be like two pipes they are going to fill a tank together. These kind of two working bodies problems only we are just going to discuss, and we are just going to see some quick shortcut approaches and some quick approaches to solve those kind of problems. That is what we are going to see in this session along with the concept. For an example, we will take, there are two people A and B, and let's assume that A is taking X days to finish some particular work and B is taking Y days to complete the same work. Now our task is to find what will be the time taken by both of them together to complete the work. We have solved many problems like this. It's going to be a very basic question only, but if we see the concept behind it, it will be even more easier for us to solve the problem even more quickly. Okay, so we will see the concept which is behind that. So as usual, we will start with the days. A is taking X days and B takes Y days. How we will start? By unitary method. First thing we will be assuming is how much is the work they are going to do. So to compute the work, what is the work, we will be usually taking the LCM of the days, right? So here we have X days and Y days. Now since both of them are in the form of variables, to find the LCM, we will better multiply the two values and we will take it to be the work. So X into Y, we will take the work as X into Y, which will be XY units. So this is the work they both are going to do. Okay, so we will assume the work as XY and we will now compute the efficiency. Efficiency means how much work they are going to complete in a single day. Okay, so A is taking X days to complete this XY units. So what will be A's efficiency? If I want to find, I have to divide XY divided by X. It will be giving me Y units per day. So A's working speed is Y units per day. Similarly, if we come for B, B is taking Y days to complete the same XY units. So B's efficiency will be XY divided by this Y, which will be X units per day. So we got both of their individual efficiency. So now what happens is they both are going to work together. So if they are working together, then how much will be their efficiency together? It will be nothing but we have to just add the two efficiency. It will be X and Y. If I add it, I will be getting X plus Y units per day. So if they work together, this will be the efficiency they will be having together. Okay. Now finally we will come to the answer part. Time taken by A and B when they work together. Okay. So if I want to find the time taken, so what's the total work they are doing? It will be XY. So this is the work they are going to do. Divided by at what rate are they working? They are working at the rate of X plus Y units per day. So if I want to find the number of days to finish XY units, I have to divide XY by this X plus Y. So this is our answer. If we carefully notice this expression and see, we will be able to observe that this XY is nothing but the product of the two values. Okay, the days taken by them individually. This product X into Y, that product is what we have in the numerator. So product divided by, come to the denominator, we have X plus Y. This X plus Y is nothing but the addition, sum of these two values. Okay, so divided by sum. So hereafter, if we want to find the number of days taken, if it is given for A how many days and B how many days, and if you want to find how many days they will take together to complete the job, we can very well easily do a very easy task. Just we have to find the product of the days, that divided by sum of the days. That's all. This will be easily giving us the answer. Let us come to the second case here. Here also we have two people A and B. Here A is taking X days to complete some particular work, and also it is given that A and B both together are taking Y days to complete the same work. Now our task here is to find time taken by B alone. How long B alone will take? How many days B alone will take to finish the same work? Okay. Let's try to carry this problem also in the same unitary method. Okay. So in unitary method, as usual, we will assume the LCM to be the total work. So we will take X and Y. The LCM is, we will take it to be XY units. Okay. XY units is the total work. And we will try to find the efficiencies also. A is taking X days to finish XY units. So A's efficiency will be XY by X. It will be Y units per day. And next, we also know that A and B together can complete Y days, can do the same work in Y days. So their combined efficiency will be how much? So it will be XY by Y. So it will be giving us X units per day. So now we are very clear that A alone can do Y units in one day, and A and B combined can do X units in one day. Okay, so now our task, first of all, we need to find how much units can B alone can do. That is, we need to find the efficiency of B. Okay, so to find, what we can do is we can simply take the difference between this X and Y. That is, we have to do X minus Y, because A alone can do Y units in one day, and B alone can do some units in the same one day. So this total is what is this together is giving us what is this X units per day. So if I want to find what is B's efficiency, what I can do, I can minus this minus this. So what I can do here is X minus Y units per day. This is what I can do. So this is what is efficiency of B. Now we can, as usual, find the time taken, number of days taken by B to complete the work. Okay, so work is XY. So this is the work to be completed, divided by who is going to do the work? B alone is going to do. So B's efficiency is X minus Y. So we have to divide by X minus Y. So this is the answer for B alone, how long it will take. Okay, so now here again, if we closely observe these terms here, we can find and observe and predict something here. See here, the numerator is XY. As usual, this XY is, as like our previous case, this XY is nothing but the product of these two numbers. Okay, these two days. So this is nothing but the product, I note it as product, divided by, see the denominator, it is X minus Y. This X minus Y is nothing but the difference between the number of days. Okay, so this is the difference, I note it to be difference. So here, from this case, what we can learn is, whenever we are given two people, and if we are given the one of them is taking this much time to complete the work, and both together they are taking this much time to complete the work. If they are giving these two values, and if they are asking us to find how long it will take the other person to complete the work, the missing one. Okay, so if we want to find the other person's time, what we can do here is we can just quickly do the product divided by difference. This will easily give us the answer. I've tabulated the two cases which we saw here. So the first one is, if you are given the person one time and person two time, and if you are asked to find what is the time taken by both together, we have to use the first rule, which is product divided by sum. And the second one is, if you are given any one of their times and both the times, and if you are asked to find the time taken by the other person, then we have to use the second rule, which is product divided by difference. Now we will quickly work out some two examples here using the rules. Let's go to the question. See here, there are two people, P and Q. P takes 40 days to complete a work, and Q takes for 24 days to complete the work. And the question is, if they both work together, how long it will take? So for this, we should be using the first rule. Okay, so here we have to use the product divided by sum. So we will be getting 40 into 24. This is the product, divided by sum of 40 and 24 is addition. So this will be 64. So now we have to simplify this. If I am going to simplify this, I can first of all cancel with 8 tables. So 8 5s are 40 and 8 8s are 64. And once again, I can cancel this 8 and 24. This is 3 times. So finally, 5 3s are 15 days is the answer for this question. So they both will complete the work in 15 days. And come to the second one. Here the question is, there are actually 3 people here, A, B and C. So it is given that B and C together can complete the work in 18 days. A, B, C, all 3 people together can complete the work in 14 days. And the question is, how long it will take for A alone to complete the work. Okay, so here B and C, there are 2 people working together, right? So here for this question, we can do a simple technique. Or what we can do is we can just consider this B and C together as a single person. Okay, so for an instance, what I am going to do is I will take this B and C together as some person X, and here also it becomes X. B and C together will become X. So our question is like, X can do a work in 18 days, A and X can do a work in 14 days, then A alone can do the work in how many days? Okay, so this is just like our second case. Okay, so what rule we can use here is we can use product divided by difference. Okay, so here if we come, we will be using the product. Okay, so product means 18 into 14 divided by, so the difference means 18 minus 14, which will be simply 4. Okay, so now again we have to simplify this one. We will be getting 18 and 4. I can cancel the 2 tables. This is 9 times and 2 times. And once again 2 and 14 is exactly 7 times. So finally 9 7s are 63 days. So A alone can do the work in 63 days is our answer. So if we go by this rule, it seems to be very easy for us to complete the problems. Friends, I hope you are clear with the concept what we are seeing today about what happens when 2 people are going to work together, the formula, shortcut approaches, everything are clear about it. And as a continuation of this session, in our next session we are also going to see what happens when we have negative work. That is, For an example, if we consider pipes and cisterns, there we'll be having a filling pipe as well as a leakage pipe. So in those kind of situations, how this is going to be applicable, that is what we are going to see in the next session. So soon we'll meet up there. See you there. Thank you so much.